All right, section 7.3 notes. How do you find the isotope of a natural base function? Okay. Natural base is E. The main use for it is using compound continuous functions. E is irrational. It's approximately 2.718281828. If you look in the book, they give you a formula for how you find E, how it compounds continuously on itself. Similar to pi and I and all those types. Okay, so just some properties with E. Use the same thing, just treat it as a letter. When you have the same base, different exponents, what you do is you add the exponents. Okay, so that would be A would be E to the 7th. Okay, the second one, you do 12 divided by 3, which is 4. And then you would subtract the exponents when you have when you're dividing, so it'd just be E to the first or just E. 12 divided by 3 is 4. You get that. C is tough, a little bit tougher. What you have to do is distribute that 2 to both of those. Okay, so you got 5 squared, which is 25. And you have negative 3x times 2 is e to the negative 6x. Okay, so you got to put the 2 with the 5 to make it squared, and then you got to, when you have a power of a power, you multiply those two together. Then from there, since you have a negative exponent right there, what you have to do is move it to the bottom. So it becomes 25 over e to the 6x. Okay, so that one's kind of tough. Just make sure when you have that number out in front, you put that as a power. Don't multiply. A lot of people like to put, do 5 times 2 and make it 10. You move it as a power, it becomes 5 squared. And then the exponents you multiply. Okay. Evaluate the expression. All these you can just put in the calculator. The first one, e to the 4th. The E button is right here. If you hit second, you see the blue is E to the power. You just put 4, and you can just get 54. They usually want you to go to 3 decimal places, so 54.598. Okay. The next one, we can do another one. Just say second E. What was this one? Negative 0.09. Okay. And you get 0.914 because you got to round it because that 9 behind it. Okay, and the last one, you can do the same thing. So it's second E. Now, since this is a fraction, you just want to be careful. Put parentheses 3 divided by 4. And you get 2.117. Okay, so basically just put in your calculator. If you don't have a TI-84, I can show you where to find it on the different calculators, Casio, whatever, but they usually are pretty easy to find. Okay, natural base functions. A function in the form y equals a times e to the rx is called a natural base exponential function. It has many of the same rules of the ones that are at graph. How you can tell if it's a growth or decay function is the r. Okay, basically, if the exponent is positive, it's going to be a growth function. If the exponent is negative, it's going to be a decay function. This is when your exponent is positive. This is when your exponent is negative. You see where it's growth and decay and how it changes. The numbers on these aren't going to be exact, so you're going to have to do some estimating when you plot them. There's going to be some decimals. Okay, so the first one says graph each function. We're just going to use graphing calculator and go to y equals. And we're going to go, let's move this over. 3 second e to the power of 0.25x. Then we hit graph. And we can see it looks pretty much like a growth function. We knew it was going to be a growth function because 0.25 is positive. So again, just use some points that are going to make it work, okay? So I'm not going to make a table. I'm just going to use these points over here to save some time. So we got negative 3, 1.4, about right in the middle. We got negative, or we got 0, 3, 1, 2, 3. And we got 3 and 6.351, so about right there. Okay, and that should be, well, let's hit second table. We'll look at some other dots. Okay, you can see if you go to the negative, um, as you get closer, it gets closer. It's the same rules as the other one. If there's no number behind it, then your asymptote's going to be 0, so it's going to approach 0 without ever quite hitting it. So let's say if we put negative 10.24, okay? Okay, and then we just make a smooth line. Again, you don't have to do these dots, but just do some dots that work for you, okay? Just make the graph look good, okay? If it asks for a table, just fill in 3 of the points. Doesn't matter which 3 points, just as long as the graph looks right. So the domain doesn't change for this one. Domain is all real numbers. It's not ARN, as someone was saying the other day. It represents something. If you don't realize it is all real numbers, then you need to write it out. The range doesn't change. You can see, let me continue to draw this dotted line. We got to get range down. A lot of people are struggling with range, but notice how all your y's, the whole graph is above 0. There's no, if you look at your table, there's no numbers that are negative. They're very small numbers, but none of them are negative. So it's y is greater than 0. You got to start making those connections with domain and range. And then the asymptote is x equals 0, okay? Because that's where the graph approaches but doesn't quite cross it, okay? Now this one, notice the negative 0.75. Right away, if I had to guess if it's growth or decay, because that negative 0.75, I would guess it's decay. You don't need to put that, but you might need it for your homework, so I want you to know that. Also, just to get practice, it doesn't say to transform it, but because that's x minus 2 right there, I know when it's parentheses and this x minus 2 is going to move right to, and because of that plus 1 there, I know it's going to go up 1. Also, I know because they have that plus 1 at the end, my asymptote's no longer going to be 0, it's going to be 1, okay? So if we want to put that right now, we can, and we'll see that later when we graph it, but we know it's going to be x equals 1 because of that last number right here, okay? But let's put in our calculator, so let's go back to y equals. Let's clear this out and move it so we can actually see our, okay, so let's go e, and let's go negative 0.75 parentheses x minus 2, and then push over to make sure it's down, and then the plus 1. And then we're going to hit graph. And if we go to the large screen, we can see it a little bit better, okay? We knew it was going to be a decay function because of that negative 0.75. And the graph, if you compared it to the original one without the x minus 2, you could, if I did another one, you could tell it moved right 2 and up 1 based off those, okay? So again, we just got to pick some points to graph this on. You can see negative 10, negative, none of those appear on the graph. So let's hit second table and look at some of these points, okay? We want points that actually appear on the graph. So the first one is 0.548. So let's plot that, 0.548. Okay, and then let's plot some other ones. 2, 2 is a good one. That's an easy one to plot. And, you can see how it's approaching 1.0052, 1.0025. It's approaching 1 like we knew it was going to, but it doesn't quite hit it. So I'm just going to put a 1 barely above 1, or pretty much on the 1 line. Okay, and from there you can just connect the dots. It's not very straight, but you get the picture. Okay, like that. Okay, so domain doesn't change. It's still all real numbers. The range is y is greater than 1 because all your numbers are above 1. It gets close to 1 but doesn't quite hit it. And you can even see that from the asymptote that we already figured out what it was going to be based off the structure of the graph. It was going to be x equals 1. Everything's got to be above that line. It's going to get close to it but never hit it. Okay. Some people are putting equal signs on these. There's no equal to on this. It doesn't hit 1. It gets close to 1 but it never quite hits it. So you got to make sure you just leave it as greater than or less than. Okay. So pretty much nothing changed from what we did on the 7.1 or 7.2 when you graph those. Okay, continuous compound interest, okay? The formula for this is A equals principal times e to the power of RT. Principal is your beginning amount, rate is expressed as a decimal, and t is the number of years. This is the way, if you can have a choice between compounding yearly, monthly, daily, or continuously, you want to pick continuously because this will give you the most money, okay? So that's why it's pretty important. And sometimes if you go to bankrate.com or something like that, they'll give you options of how much you want to compound. All things being equal, the rate's the same, time the same, the principle's the same, but it's how many times you want to compound. You want to go with E, okay? Or you want to go with compounding continuously because they'll give you the most money, okay? So it says you deposit $800, which is your principal, and an account that pays 0.06 or 6%, which is your rate, which you're going to write as 0.06 later. Got to change to a decimal. Annual interest compounding continuously, so we know we're going to use that formula, was the balance after 3 years, which is your T. Okay, so we're just going to plug that into our formula. We're going to do the amount equals the principal, which is $800, E to the power of R, which is 0.06. We're going to put this in parentheses, times your T, which is 3 years. Okay. And from here, again, you can pretty much put this in your graphing calculator. Okay. If I scroll this down here, oops. Oh, I don't know if I'll be able to scroll down. Well, let's just plug it in. Okay. So second quit, get to the main screen, clear this out. We got 800 E to the power. Again, we want those parentheses. Oops, I did something wrong. Let's hit delete, delete. Okay, let's go parentheses. And it was 6%, so 0.06 times how many years? 3. Okay, so you can put it in pretty much just exactly how it looks. Hit enter, and we get our answer. We get $957 and about 77 cents. So that'll be our answer when we solve that. A equals 900, put a dollar sign, not a very good dollar sign, 900, let's just do that again. $957.77 would be our answer. Okay. So pretty much you can put that in the calculator and solve it. You can simplify if you want to first, but as long as you put in the calculator correctly, it's going to get the right answer. So your exit step is to solve another one of these. Now your principal is 4,000. Your percent stays the same, so 6%. You're still compounding continuously, and it's after 2 years. So solve that. And if you have any questions, email me. And thanks for watching.